Hello everyone and welcome to On the Spot STEM. Today we will be tackling the Aime I number 4 from the 2019 contest. Now this question reads, a soccer team has 12 available players and a fixed set of 11 players starts the game while the other 11 are available as substitutes. During the game the coach can make up to as many as, which means it could be 3, 2, 1, or 0, where any one of the 11 players in the game are replaced by one of the substitutes. No player removed from the game may re-enter the game, although a substitute entering the game may be replaced later. No two substitutions can happen at the same time. Now we want to find the number of substitutions that can be made, including the possibility of making no substitutions. Now, just this one parenthesis over here that says including the possibility of making no substitutions just makes me think that this problem calls for a casework solution where we have what if he makes 0 substitutions, what if he makes 1, what if he makes 2, and what if it's 3. Now, we just can list out the number of ways each of these cases can happen. So let's try doing that. Now, for 0, obviously, there's only one way that he can just not remove anybody. And this can be seen because a fixed set of 11 players starts the game. That means the same 11 players will always start the game, and you're just making no substitution, so there's only one way to do that. What if we make one substitution? Well, what we can think of this as is the one substitution can be split up into two different things. There are 11 choices for the person he can take out, and 11 choices for the person he can put in. Now, 11 times 11 ends up being 121. So this is actually the number of ways that 1 can be made if he only makes one substitution. Now, what if they make 2 substitutions? Well, we can essentially think of this as 2 spots. And each of these 2 spots can be subdivided like earlier into who gets picked to leave the game and who gets picked to enter the game. So obviously the first substitution can be made with 11 ways for the first person to be taken out and 11 ways for the second person to be put in. However, it changes a little when we get to the next substitution. We can still pick any of the 11 players to take out of the game, but since the first player who left, which is this guy, cannot be put back into the game, we have one less choice for who we can put back. So we have 11 minus 1, which equals 10 ways to pick the second person. Can happen, we multiply the 2, and we get that as our answer. Now, I'm just going to leave it unsimplified for now because that does look like it's going to take a while to multiply out, and maybe we can do something with mod 1000 later. So what if we do 3 substitutions? Well, using the same logic as earlier, we have 3 different possibilities, 3 different substitutions that are happening, and each substitution can be subdivided into who's leaving the game and who is entering the game. Now, like the 2, it's going to be 11 and 11 for the first substitution, and it's going to be 11 and 10 for the second substitution. And for the third substitution, if we use the same logic as we had before, we still have 11 people we can take out of the game because the substitute entering the game may be replaced later. However, we have 2 people who have left the game after playing. So that's 2 people out of the 11 substitutes we have that we cannot put in. So that gives us only 9 possibilities to pick this last one. Now here comes the calculation part. We know that we can write this as 1331 times 10. Because that's just 11 cubed, which is the first 3 11s times 10. Here we can write it as 1331, which is the first 3 11s, times 10 times 11 times 9. And that's just 99 times 10, which is 990. Now, we want to add up all of these values. 121, 1331 times 10, 1331 times 990. But we notice that the problem asks us to find the remainder when n is divided by 1,000. This actually becomes a lot similar because if we take 990 mod 1000, this is actually congruent This is actually equal to 1331 times negative 10 mod of 1000. So we notice that if we add 1331 times 10 mod 1000 and 1331 times negative 10 mod 1000, these actually just cancel out. So our final answer actually ends up being 121 plus 1, and that gives us an answer of 122.